Standard 12 CBSE previous year's questions answers of physics. So today's topic is dual nature of radiation and matter. Here we discuss about photoelectric effect, Hertz and Leonard's observations, Einstein photoelectric equation and particle nature of light. And we have matter waves, nature of particles, the Broglie relation, and only the experimental detail is not required, only the conclusions of Lewisian-Germer experiment. So let's resume our discussion. This question was asked in 2016, 2 marks question. Plot graph showing variation of the Broglie wavelength lambda versus 1 by root V. So V is what? V is the accelerating potential for two particles A and B carrying the same charge but different masses. M1 M2 of A and B are different, okay, and M1 is greater than M2. So which one of the two represents the particle of smaller mass and why? Okay, so we have to plot the graph between lambda versus 1 by root V. So what is the relation actually? We know that the Broglie wavelength is related to charge, okay, and what is relation? Lambda is equal to h by root over 2mqv, where m is mass, q is charge, v is the accelerating potential, correct? So now if we plot 1 by root v along x-axis and wavelength lambda along y-axis, okay, then A is, which is inclined at an angle theta 1 with the x-axis, A is along this. OA represents A, and OB, which is inclined with the x-axis by an angle theta 2, so this is representing B. So this is the plot, okay. Now the second part of this question asks, which one of the two represents the particle of smaller mass and why? So thus lambda is inversely proportional to root V, correct? Hence it will be a straight line. It is a proportional relation. So in the x-axis we have not given root V, we have plotted 1 by root V. So we can say that lambda is proportional to 1 by root V. So it's a straight line. Now, and the slope of the line is tan theta. Tan theta is how much? H by root 2 mq. So in this relation, lambda is equal to h by 2 mq q into 1 by root V. So this is, if this is y, this is m, this is x plus c. So here, if we compare with the equation of a straight line, then the slope of the line is 1 by, that is h by 2 mq, this is h, correct? H by 2 mq is the in place of m, so this is the slope, and constant is 0. There is no constant, that is why it is passing through the origin, correct? 0, 0. So since m1 is greater than m2, therefore theta 1 should be less than theta 2. Here it is inversely proportional to the square root of m. So where mass is more, tan theta will be less, correct? So since it is given m1 is greater than m2, therefore theta 1 will be less than theta 2. Okay, thus the smaller mass m2 will have greater slope. That's the explanation. Next question. For a screenshot, I am removing this. Next question. Write Einstein photoelectric equation and mention which important feature in photoelectric effect can be explained with the help of this equation. So what is photoelectric equation? Einstein, as per the Einstein photoelectric equation, what is said, that suppose we have a metal piece here, metallic surface here, okay. Now whenever light incident, a part of the light energy, suppose h nu is the energy of the incident light, okay, E. And the energy required to knock up the electron, to emit the electron, to release the electron from the surface, that is suppose E0. E0 is how much? H into nu 0, where nu 0 is the threshold frequency, okay. This much energy is used for knocking up the electron, and remaining part of the input energy will be used by the particle for as a kinetic energy, okay. So entire energy E is used up E0 plus half mv square, okay. So h into nu, where nu is the incident frequency of the incident light, h is the Planck's constant, is h into nu 0, nu 0 is the threshold frequency, half is mass, m is mass, and v is the velocity attained when it is ejected from the surface. So this is Einstein photoelectric equation. So let's see. The maximum kinetic energy of photoelectron gets doubled. This is the second part of this question. When wavelength of light incident on the surface changes from lambda 1 to lambda 2. So kinetic energy gets doubled when the wavelength changed. Derive the expression for the threshold wavelength lambda 0 and work function. What is work function? The minimum energy required to release the knock up the electron from the metal surface, okay. So we'll discuss this. In photoelectric effect, incident energy is used up for ejecting the electron, that is called the work function, and rest of the energy is used as kinetic energy, okay. So this is what is Einstein photoelectric equation, okay. This is what we have explained here, where nu is what? Nu is the frequency of the incident photon light, okay, communicated through photon. Now nu 0 is the threshold frequency, m is the mass of the electron, and v is the velocity of the electron attained once it is released from the surface. So v max square is the square of the velocity, okay. So maximum velocity attained by the ejected electron. Now important feature is kinetic energy of the ejected electron depends linearly with the frequency of the incident light, okay. And second is there is minimum frequency of incident photon below which photoelectrons are not emitted, okay. This minimum frequency is called the threshold frequency. So this nu 0 half m v square, okay. Remember this, it is not dependent on the brightness of the incident light. It is dependent how much frequency it has and what is the frequency required to remove the electron, okay. So it depends on very much that whether threshold frequency is obtained or not, okay. So this is now we have velocity of electromagnetic wave is frequency to wavelength. So frequency is reciprocal of wavelength, c by lambda. So if we replace h into nu, nu is what? C by lambda. H into nu 0, nu 0 is the threshold frequency, it is c by lambda 0, correct. C is lambda into nu. So we can represent nu as reciprocal of c by lambda, correct. So we have replaced nu by c by lambda, nu 0 by c by lambda 0 square, plus k max. K max is kinetic energy, half m v square, correct. Now, given kinetic energy of the photoelectron gets doubled. To solve this equation, we will use this equation number 1, okay. Now, lambda 1 to lambda 2. So initial when the wavelength is lambda 1, then we have C by lambda 1 is equal to C by lambda 0 plus k max. When the wavelength is lambda 2, then incident energy will have C by lambda 2, but this is the work function, this is fixed for the metal, correct? And the kinetic energy gets doubled, so it is 2 times k max kinetic energy. Now putting the value of k max from equation 1 to equation 2, okay, so here k max equal to how much? From equation 1, k max equal to h common, c common, 1 by lambda 1 minus 1 by lambda 0, correct? So put this value in equation 2, then we find that lambda 0 equal to lambda 1 lambda 2 by 2 lambda 2 minus lambda 1, okay? So this is our answer. So you can take a screenshot. Next question. Show graphically the variation of the Dabroy wavelength lambda with potential V through which the electron is accelerated from rest. Okay. So lambda versus root V, correct? So if we put root V along x-axis and along y-axis lambda, then we find that Dabroy wavelength is given by lambda is equal to h by mb. What this equation states? This is Dabroy wavelength. When it is a particle in motion, it will emit wavelength. It will emit waves. Okay. Now what is the wavelength associated with a moving particle? It is h. H is Planck's constant. M is mass of the particle. V is velocity of the particle. Okay. So higher is the velocity of the particle, lesser will be the wavelength, correct? Now we know that this is mv is what? Momentum of the particle. So it is h by p. P is represented as momentum. P is equal to mass into velocity, correct? So P is equal to mv. Now what is relation between mv and energy? So energy we have, energy is equal to how much? Half into m into v square, kinetic energy, correct? So if we take 1 m, if we multiply mv square with m, then we'll get denominator m also, correct? So it is equal to m square v square by 2m, but m square v square is momentum square, so p square by 2m, correct? So we can represent this mv, that is p square is equal to 2m into e. So p is mv, p is root over 2me. So here p is represented as root over 2me, correct? So what is e? E equal to q into the potential, charge into potential is equal to energy, correct? Okay. So lambda is equal to h by, from equation 1 and 2 we get lambda is equal to h by p. So in place of p we can write this. So lambda, the wavelength, is equal to, is inversely proportional to the square root of, wavelength is inversely proportional to the square root of potential applied, correct? So lambda into root over v is constant. We know that in order to replace this proportionality sign, we need a constant. Then this proportionality sign can be replaced, this constant, equal sign and constant, root over v. So lambda into root over v is constant. So graphically it gives a hyperbola as shown. So this is the, continuously if we increase v, then lambda will decrease. So it is a basically hyperbola, correct? So let's take a screenshot of this answer. Next question. In a transistor, doping level is base is increased slightly. How will it affect collector current and base current. This question related to electronic devices anyway. In this session we'll take it up. What is doping? Doping is the addition of impurity with the intrinsic semiconductor. Then it becomes, if you add atoms of different metal to a natural semiconductor. Natural semiconductor are called intrinsic semiconductor. Okay, so we get when it is added, then this process after adding is called doping. Okay, addition of impurity is called doping. Correct. So it says in a transistor, doping level in base. In transistor we have base emitter collector. So doping level in base is increased. How will it will affect the collector current and base current? This is one more question. So we know that the collector current is approximately beta times the base current. Beta is gain factor. Okay. So collector current will decrease and base current will increase. Correct. So this is the impact of increasing the doping level. An electron, next question, an electron and a photon each have wavelength 1.0 nanometer. Find their momentum, the energy of the photon, the kinetic energy of the electron. So we have three parts of this question, three marks allocated for this. Let's see. So lambda is given as 1 nanometer. 1 nanometer is 10 to the power minus 9 meter. Okay, so for electron we have h by lambda, and h is constant, Planck's constant, 6.63 10 to the power minus 34. Lambda is 10 to the power minus 9. So the momentum associated with this 6.63 10 to the power minus 25. So energy of the electron, energy is equal to how much? hc by lambda. Okay, so h into c is velocity of light in vacuum, 3 into 10 to the power 8, and this. So what is mass? Mass of the electron is how much? Mass of the electron is equal to, if we put lambda here, 1.6 into 10 to the power minus 19, correct? So it is 1243 electron volt, and 1 electron volt is 1.6 10 to the power minus 19 joule. So energy is equal to, in the last question we have explained that energy is equal to p square by 2m. So momentum is square, okay, by 2m, 2 times m. So okay, so in this third part of this question is the kinetic energy of the electron. Okay, so kinetic energy of the electron is, this is equal to energy, and energy is equal to h into nu, first part h nu, h into nu is c by lambda. So for photon there is no mass, rest mass of photon is 0. That is why we have calculated energy in this way, c by lambda. But for electron we have p square by 2m. M is the mass of the electron, which is 9. And charge of the electron is 1.6 10 to the power minus 19. Okay, this is the charge. Okay, so this is 1.52 electron volt, and 1 electron volt is 1.6 10 to the power minus 19 joule. Correct? Okay. Next question. So next question. An alpha particle and a proton are accelerated from rest by the same potential. Find the ratio of the Broglie wavelength. Correct? So the Broglie wavelength is given by h by mv. Correct? And energy is equal to how much? Energy is equal to charge into the potential v. Correct? So this is equal to the kinetic energy. So charge into potential is equal to kinetic energy. So EV is equal to half mv square. So if we multiply both sides by m, then we get m here, m square here, correct? So 2m into EV equal to m square v square. This is the momentum, correct? So root over 2m e into v equal to p, momentum mv. So lambda from this equation, lambda equal to how much? H by root over 2m ev, correct? So if v is constant, charge is constant, then lambda is proportional to root over m, correct? Now let us compare the proton mass with the mass of alpha. We know that alpha is nothing but the helium atom, so mass is 4 amu, and for proton mass is 1 amu, correct? So alpha particle, the mass of alpha particle is 4 times the mass of proton. So lambda is equal to lambda of alpha, lambda of proton if 1 by root m, then lambda of alpha, wavelength of alpha is 1 by root over 4m. So we have to find the ratio. So ratio is root over 4 by 1, so 2 is to 1, correct? This is the answer. You can take the screenshot. Next question. Write Einstein photoelectric equation. State clearly the three salient features observed in photoelectric effect which can be explained on the basis of the above equation. Okay. So this question was asked in year 2010, 2 marks question. So we have already explained that the incident energy of photon is used up to eject the electron. This energy is called the work function, and remaining part of the incident energy is used by the ejected electron as kinetic energy. So it is K max. K max is the maximum kinetic energy at n is equal to half mv square. So it is maximum kinetic energy, this much, is equal to h nu minus work function. So h nu minus h nu 0. Now, a part of the energy of the photon is used in liberating electron from the metal surface. This part of the energy is called the work function of the metal, correct? The rest of the energy of the photon is used to get the maximum kinetic energy to the emitted photoelectron, correct? Because electron energy is emitted in the photons of photons. Okay, so photoelectron will use up the remaining part of the energy to move, okay, for kinetic energy. The negative potential on collector at which photoelectric current becomes zero is called the stopping potential. Okay, suppose we have electrons are emitted from this is we have collector. Okay, so suppose like in case of valve system triode, we use a grating here in between the collector and emitter. This is a grating. So this is the modern concept of transistor. But in valve system, how we control the flow of electron? We put a negative potential here. So when the electrons are emitted from the surface, these electrons can be prevented to reach the collector by applying the negative potential. So this potential which is applied on the grid to stop the electrons, to stop the emitted electrons, is called the stopping potential. So if we supply this much energy to stop the electron, it will stop emission. So the negative potential used, this stopping voltage varies linearly with the frequency of the light, but depends on the type of material. For germanium it will be different, for silicon it will be different. So K max is equal to H minus H into nu minus nu 0. Okay, so this is called the stopping potential. Okay, the energy required to stop the emission. Next, for what kinetic energy a neutron will associated with the Abroad wavelength be 1.32 into 10 to the power minus 10 meter. Okay, we have to find out the kinetic energy. Okay, so lambda is given 1.32 10 to the power minus 10. Mass of neutron we know 1.675 10 to the power minus 27 kg. So we have lambda is h by mv. So put the values, correct, h, and v is the velocity, correct. So velocity is this. If we know the velocity, then we can find out the kinetic energy. So that's this much joule, correct. So easy question. Okay. Next question. So we have ultraviolet UV, okay, ultraviolet light of wavelength 2271 angstrom from a 100 watt mercury source which radiates a photocell made of molybdenum metal. Now if stopping potential is 1.3 volt, estimate the work function of the metal. How would the photocell respond to high intensity? Okay, 10 to the power 5. Red light of wavelength 6328 angstrom produced by helium neon laser. Okay, plot the graph showing the variation of photoelectric current with anode potential for two light beams of same wavelength but different intensity, correct. So we have work function equal to h nu minus h nu 0, okay, which is stopping potential E into nu 0, correct. So h nu is represented by c by lambda because velocity is wavelength into frequency, correct. So V0 is the stopping potential, charge into potential is energy. So from this we find that this W0, okay, it is this much, 6.64 10 to the power minus 19 joule. So threshold frequency is how much? Okay, h into nu 0 is work function. So threshold frequency is equal to work function by h. So it is represented by W0, work function. So this is equal to 1.0 10 to the power 15 hertz. The frequency of red light is c by lambda. So it is c is velocity of light in vacuum 3 into 10 to the power 8. Lambda is given in the question. So it is 4.74 10 to the power 10 hertz. As the frequency of red light is less, so let us compare these two frequency, 1 10 to the power 15 and it is 4.75 10 to the power 10. So which one is less? This is less. Okay, this is higher, 10 to the power 15, this is 10 to the power 10. So as the frequency of the red light is less than the threshold frequency, so there will be no photoelectric emission with a helium neon laser because it is not giving that much energy, not imparting the work function, correct. So now in the negative side of x-axis it is the retarding potential, this is the anode potential. So for two different intensities, if I2 is greater than I1, so we get at this potential the emission of photons will stop here. This is stopping potential, and as we increase the anode potential, this increases. So this is the graph. Okay, so for different intensity, if I2 is more, then this is the graph 2. If I1, then compared to I1, correct. When the intensity varies and anode potential is increased, then we will get different plot, correct. So this is the graph. So next we'll discuss about atoms and nuclei.